My name is Dor, and today we'll speak about bypassing modern authentication to SSO. So let's go. I have a question for you guys. Do you think that modern methods are really a security charm? Do you think that just buying FIDO security keys or rolling an authenticator app will um, just just be quick and easy and will provide all the protections you need? Let's check it out. So before we begin talking about attacks and stuff, let's discover which kind of modern authentication methods we have. The first purpose of these methods is to bind a physical real-life device to virtual identity. We want to check and validate that the integrity of every user and device is actually the one that is authenticating to the web application. These modern methods have modern protocols that were created especially for it. There is SAML, WS-Fed, there is OpenID Connect, OAuth, which is the infrastructure, and some extensions for familiar protocols such as Kerberos certificate-based authentication. Modern methods can be either authenticator apps, time-based textual passcodes, third-party identity providers, and obviously FIDO. So today we will discover and focus specifically on FIDO as my original research was on. So yes, FIDO2 is actually a lot better than the legacy password. It is based on public key cryptography. It has physical or biometric features. It is bound to the origin, the domain origin, to prevent phishing attacks. And it's passwordless. And passwordless, I mean that if it doesn't have biometric feature, you still need password for the security device. And alongside this FIDO physical key, you have new modern authentication protocols introduced. We have WebAuthn and we have CTAP. WebAuthn is in charge of the communication from the browser to the relying party, the application itself. And CTAP is from the browser to the physical device in your operating system. So I'd like to talk to you a little bit about some basics of WebAuthn because today we will focus on the communication between the client and the relying party itself, the network communication. So the browser, because it's exactly in the middle between the physical device and the relying party, it is in charge of the authentication itself. WebAuthn has two authentication steps. There is the enroll and the sign in. Relying party is the third-party application that is in the cloud remotely. And the second one is the sign-in, obviously, that is being repeated over and over again each time you need to sign in. So the first step is enroll. Its purpose is to bind the physical key, security key to the user account. The registration step of the physical security key is the relying party. It triggers the browser's credentials create. The sign challenge is sent by the relying party to the browser. There is an optional attestation statement to validate that the security key is actually manufactured originally by the provider you wanted and was not forged. The client creates then a credential pair locally on the device alongside a private and public key and the domain origin that it was sent from the uh, the application itself, the relying party, and a unique credential ID that identifies each account from a different one. So then the credential ID alongside the public key is sent back with the server's challenge back to the relying party. The second step is the sign-in. Well, it is actually kind of the same of the enrollment challenge, except one thing. The signature that is created by the device is unique pair authentication, and it is signed with the private key itself. Then the public key that was sent in the first stage will be used by the relying party to validate that the signature was actually created using that private key. So let's see how this sign-in looks like. There are two protocols here. There's the HTTP protocol and there is the WebAuthn. The first thing that the user requests is the login page. And then the WebAuthn, we can see that the relying party actually triggers the browser and not the other way around. And lastly, after the entire authentication signing has ended, there is a session cookie that is granted to the browser and the clients to use afterwards. So the session cookie that is created is a typical usage of creating a session that will hold for a longer period of time. So I did mention some key terms that that FIDO and WebAuthn uses to actually create the integrity part to protect from man-in-the-middle and phishing attacks. The challenge that is sent by the relying party to the client must be returned as is to validate that the authentication request itself cannot be replayed. The domain origin is actually to prevent phishing attacks and to validate that the domain origin is preventing the use of a different domain that is usually used for phishing. And lastly, that the attestation protection, it is validation of the physical key is actually manufactured by a valid manufacturer. So this is actually a commercial that is published from one of the big vendors of FIDO. And does it actually protect from man-in-the-middle as advertised in malware attacks and all of these attacks? So let's see what's the problem. So FIDO is actually really good at protecting the integrity. But as we see a typical authentication and user usage, we see that the authentication itself is just a small part at accessing the entire sensitive data of the user. So once the authentication has ended and the authentication is actually protected by FIDO, the entire authenticated session is not protected. And let's see how's that. So let's talk about session hijacking. Session hijacking is unauthorized takeover of an active session between a user and a web application. And it is also called cookie hijacking. And it's when an adversary intercepts the victim's session and then the user authenticates a FIDO security key. Upon success, as we saw before, an application typically generates a session cookie. The adversary, if the session cookie is replicated and achieved, may bypass the entire FIDO authentication, and then it may gain unauthorized access to the application. So let's see how, in which context the man-in-the-middle adversary is placed. We can see in the diagram, in the following diagram, that the context of the man-in-the-middle is after the authentication is complete, after the session cookie is created. So I took an example of Yubico Playground because Yubico demonstrates the security feature of FIDO. And it's a simple direct application. And FIDO actually authenticates directly without any other players of the authentication itself. So let's see what happens in the following demonstration. So we can see that I entered my credentials. I used the FIDO automatic single sign-on, and my FIDO doesn't have biometric features, so I entered the password, and I successfully signed in. I used the Fiddler application to safely decrypt the entire session, the entire TLS session. And then I use a different browser, and I use an extension, and I stole the session cookie. And there is no validation on either the browser or actually anything. And in this demonstration, I actually log in and I bypassed the FIDO authentication, and I actually removed it from the user's profile. Like I access the sensitive data, and I managed to remove the security key of the victim. So exactly what we have seen, I managed to successfully bypass the FIDO security key authentication. I used the session cookie I managed to steal, and then finally I bypassed the authentication and removed the user's security key. So the real question is, does man in the middle still exist today? So yes, it is difficult. TLS made it really hard, and decrypting is not something that you can do easily. But TLS protects the passage, and I believe that sessions and session cookies and session tokens should not be replicated. And there is all the kind of attacks of SSL downgrade, spoofing, and state actors is not an imaginary scenery anymore. A lot of state actors have the ability to steal root certificates and attack, for instance, Active Directory certification services. So it's not something that was taken out of some scenery, imaginary scenery, or James Bond or whatever. It actually really happens, but nobody really talks about it. So a little bit of man in the middle in the news. We see a lot of vulnerabilities of VPNs and SSL downgrades. So we do see some news about it, but not a lot. But it does happen. And I think when creating and designing authentication methods, this should be taken, because other protocols that we know, for instance, LDAP and SMB, has some protections over after the authentication ends. So we've just seen the simple scenario, but real life is actually more complicated than that. Single sign-on provides an identity access to unrelated applications using a single set of credentials. And actually, many enterprises, almost I think all enterprises, uses single sign-on because it's very convenient, and it provides just in a single entry of the username and its credentials. It provides a convenience and access to many applications at once, because we all want to work efficiently and quick. And SSO usually works over OpenID Connect and SAML protocols. And SSO integrates with various modern authentication methods. And again, we specifically talk about FIDO, but we may perform the man-in-the-middle attacks on other kind of authentication methods. So in SSO, both grant the client access to the relying party applications, and there are famous providers that actually does it for you. There is the Entra ID SSO, the Okta, Ping Federate, and many, many more. This is how it actually looks like. We have the Ping Federate, and we have the Entra ID SSO by Microsoft. And now we see a diagram that actually there are more players to the authentication itself. There is the relying party, and there is the IDP provider, the federation endpoint, and more protocols are playing. And we can clearly see here that the context of where FIDO is protecting or the other authentication methods is the federation endpoint and not the application itself. So Entra ID SSO has many features. There is a different endpoint for every SSO protocol. There is the SAML and the OpenID Connect. And it uses its native applications by OpenID Connect by default. The credential ID has a tenant matching by the physical device, but the relying party origin is always login.microsoft.com. So man in the middle on the IDP attack. This type of attack leverages man in the middle interception of data and retransmits data to the server or other system. So the data that we are looking for is the session token itself created by the identity provider. When an adversary intercepts the traffic, the context should be the application itself. When I am man in the middle, I don't even have to intercept the authentication itself, which is in a different context. I need to just catch the session token or the refresh token. And we see that most applications, even the native ones, does not validate the token itself. And it doesn't matter if I achieve the token, if I use it from a different device, a different location, or a different user agent or browser. So now we can see in the complete diagram that the context of the attacker or the adversary is in the relying party itself and not the identity provider, the federation endpoint, where the modern authentication method is actually located. Let's see an attack of Entra ID SSO demonstration. Again, I used Fiddler to decrypt the traffic conveniently. And in this use case, I tried to authenticate to Azure Management Portal, which consists a lot of sensitive data. I tried to authenticate. I used the authenticating mechanism of Entra ID SSO. I used my security key. I entered my security PIN code. And I successfully sign in. And we can see all the sensitive data that I use. Then I managed to intercept the data as an adversary and take the session token itself. So the session token is by default lasts an hour. However, there is a concept in OpenID Connect called refresh token. Refresh token can generate session tokens, and it may, if I achieve the refresh token, I may have an unauthorized access for a longer period of time. We can see here that I actually changed the browser that I'm using to see if there is a validation of the browser itself. And surprisingly, there is no validation of the browser or location or number of usages. And after I modified the network packet itself, I may continue the impersonation, allow the traffic to be continued, and I bypass the modern authentication methods. And we can see that I access the private data and resources in the Azure Management Portal. So what we've seen, a physical device is in most cases part of an authentication chain. So there is not just a direct approach, there is more players to the authentication chain itself. Modern authentication method is in the context of SSO. The FIDO origin is not the application itself. It's the it is not bound to the relying party itself. And the adversary doesn't have to be man in the middle in the SSO context or the IDP provider. You just have to intercept the application itself. And then lastly, we managed to replay the access token and create session cookies that will last longer. So let's talk a little bit about the weakest link of authentication. Federating the authentication actually weakens the end-to-end security provided by modern authentication techniques, because the relying party or the application does not have the enough power to validate the session created by the identity provider. Only validate it was signed by the identity provider itself. And if you add more and more authentication methods to the chain, it will rely on the weakest link of the entire chain. So more methods does not mean that it is necessarily better. But don't you worry, because not all is lost, and a suggestion is already proposed. In 2018, there was an RFC suggestion that binds the authenticated client to the entire authenticated session. Token binding 1.0 will bind the modern authentication to its underlying TLS handshake. It is again used by public key cryptography that extends beyond the authentication context itself, as we've just seen earlier. WebAuthn may be used as an infrastructure to securely deliver. We can actually use FIDO or modern authentication methods to deliver the signature of the TLS itself to the relying party, and use the great features that we've seen before that FIDO provides. Token binding actually may protect both the direct approach and the SSO provider. There is the provided token binding, and there is the referred token binding. And it's so strong, it may break your SSL inspector products, because you need to redesign those SSL inspector products to match how the token binding works. So how does it work? Upon client server hello, the token binding extension is available. The two endpoints agree on certain TLS fields that the client will sign. Exactly like in WebAuthn, the browser creates a long-lived private and public key pair. The client sends a signature alongside the public key, and it is sent after the initiation of the TLS handshake over the HTTP layer, the application layer. The server verifies the signature and binds it to the session token. which brings the public key mechanism to session tokens. So in the following diagram, I added the TLS handshake, and we can see exactly how it looks like. Once the client server hello, and with the token binding extension, agree on those certain fields, then the client or the browser create a long-lived certificate with a public and private and public key. And then the entire authentication mechanism continues. As we've seen before in the direct approach, in the simple use case, the relying party requests the login page, and FIDO triggers the navigator.credentials.get function, and the FIDO or other modern authentication continues. Then after the session, before the session token is generated, the WebAuthn protocol, or the FIDO, delivers, in addition to the signature of the FIDO key itself, the token binding signature. Then the relying party verifies it and binds it to the session cookie itself. And once the session cookie is sent back to the device, this session cookie is unique to this authentication and this client. And in this way, we can provide and we can make sure that the entire authentication and the session cookie is protected from the usage of other devices and other adversaries. So my initial research occurred in April and May 2023. And I noticed before coming here that Chrome dropped support in version 70 due to low adoption rate. And Ubico Playground actually edited it and then removed it. Well, it's a playground and they can actually do whatever they want. It's not a real application. And Edge is the only browser that supports token binding, and for the native native application, I submitted an MSRC report on how to bypass those modern authentication methods and replaying the OpenID Connect token. MSRC replied that it is not a vulnerability. Well, it is not a vulnerability. It is an attack surface. But 4 months later, a token protection feature was presented. So let's look at that. Token protection is a conditional access feature in preview. And as I marked in Microsoft documentation, token theft is thought to be relatively rare event, but the damage from it can be significant. So not my words, their words. And it is bound to TPM, but in the network authentication, TPM acts exactly like FIDO. It uses the same WebAuthn protocol. So if you allowed TPM, so why not give a generic FIDO and use your own security key device? It is difficult to implement. The picture was taken from the documentation on the configuration needed, but it is actually in preview feature. And I am certain that later on they will provide an easier way to implement it. And right now it is very limited to specific Windows clients, modern clients, and specific applications. Such as OneDrive, Teams, Power BI Desktop, and Visual Studio modern versions. So thank you for implementing the token binding feature. And I'm really curious to know what will happen with the others. So after you've seen it all, you ask yourself, what should I do next? So, as I mentioned earlier, it is not enough to buy FIDO security or roll out authenticators, apps with numbers or TOTPs. You need to understand your threat attribution when deploying your authentication mechanism. In sensitive cases, I really recommend to use the direct approach and provide all the protection features directly to the application, and learn the backend, because you need to choose the right FIDO library if you're a software developer. Most libraries need modifications and configurations, changes to the attribute threat, and understand the integration between each authentication mechanism, because if you add more, it doesn't necessarily mean you're more protected. And you need to monitor your authentication traffic for attacks and anomalies, even if you have multi-factor authentication. And lastly, add token binding if supported by your application. And if you do that, make sure you take into consideration the SSL inspection products, because we already understood that it may break. So thank you very much, and I'm here for questions. Yes.
I have a question for you. I actually first came to know of your presentation when it had a different and slightly more provocative title, but
That's true.
I noticed the narrative argues that session hijacking allows you to circumvent modern authentication, which I totally accept. For full disclosure, I'm a contributing member to WebAuthn, so I understand it reasonably well. And certainly session hijacking and a compromised client are completely outside the threat model of WebAuthn.
Mm-hmm.
But one could argue that the most prevalent form of session credential hijacking actually occurs through authentication phishing in the first place, right? Because that's how you can obtain and how many black marketed long-lived session credentials are first procured. And my question to you is, isn't it also equally valid to argue that the use of a phishing-resistant authentication mechanism like WebAuthn and FIDO actually helps protect this ecosystem by mitigating that vector of initial session credential theft, which is phishing, instead of actually being, the way you portrayed it as circumvented by something that was actually difficult to achieve in the first place if you were using phishing-resistant authentication to start with.
So phishing resistance, phishing as man-in-the-middle attack is just one type of man-in-the-middle attack type. And as we've just seen, there are others. So yes, you protect from phishing itself, but are you protected from other men in the middle? We've seen that state actors does a lot of trouble in this world. Do you agree that even if you have this phishing protection, that the session itself should not be replicated?
I totally agree. I did mention I think that's totally outside the threat model for FIDO, right?
So yeah, I think that phishing is the easier cases, the easier use cases, but if you still can overcome it and you are really an enthusiastic adversary, then it
just seems to me to be the most scalable, remotely scalable form of doing session credential hijacking.
So you have the phishing layer, which is in most percentage, but you still have an additional and other types of attacks. And
fair enough.
Thank you. Yes.
So, interesting subject matter.
Mm-hmm.
I have to agree with some of the things that he was saying from a thought perspective. I've got two questions. The first is, and you briefly mentioned passwordless authentication.
Right.
Which, on your first slide, I have a superpower. I can look at anything in under 30 seconds, spot the only typo. you had 5 S's in passwordless, and on credentialed you had 2 L's and not enough E's. But that's just to correct for the next time.
Okay. Thank you.
How in passwordless, the problem I always have with it is how does the human participate? How does this thing up here, which is what I'm really authenticating? I'm not authenticating this or this
Right.
or this.
Right.
How does this participate in passwordless?
Well, you see, if you have the, if in specifically in FIDO, you have biometric features, so it makes it a lot easier for this to perform the authentication, because if you can't change that and you can't change that, but if you have a PIN code, so it's not really passwordless because you don't need to remember a lot of credentials. You just need to remember just one PIN code, but you still need to remember that.
Right.
So it's not exactly passwordless.
It's a moniker problem, and I've argued that every time somebody gives me an answer like yours. So my other question is you were talking about approaches to fix it.
Mm-hmm.
Well, how about perfect forward secrecy? Right? So you
Okay.
talk a little bit about implementing TLS
Right.
into the session cookie, but I think the only way that you really make that work is by going with perfect forward secrecy processes in the session cookie. Because if you don't do that, then okay, you've got a bound session cookie. Great, I just steal that, and it's the same forever.
Yes, but if you steal that, you still need to create the TLS session because
If I'm
you
a state
force it.
If I'm a state actor, I have what I need. If there's no perfect forward secrecy.
Well, not necessarily, because it's unique and you still need to steal from the device itself. The private key was created to the TLS session itself. And if you achieve that, then you got onto the device itself, then what can you do?
But that's that's presuming the traffic to the client from the relying party, because that's the only time the private key makes a difference.
Well, if you got into the victim's device, then it will be a lot easier. It's
that's
like
game-
it's
that's
just
game
like
over
malware. It's just like a malware on the device itself. But if you're not, and all you need to do is intercept the traffic and gain access to a web application, which is completely different than just going into the user's device. Yeah, don't you agree?
Yes, I'm going to yield to somebody else because
Okay.
we could go on forever.
Yeah, we can talk about it later. Yes.
Well, I think we can all agree that security will never be 100% perfect. So, but just from the attacker's point of view, if you have that token binding in place, what would they see if they do try to put in the session cookie? Will they see, hey, you have to log in, or will they see an error?
I like both of those options.
Okay. Just because, if you run into that, then you have, that kind of metadata of, where do I need to go next?
Well, in my personal opinion, I'd like to give as less information to the attackers.
Right.
So I would just give another login screen, but that's my personal opinion.
Awesome. Thank you.
Yeah, you're welcome.
Cool. So thanks for the talk. It was very good. So
Thank
I was
you.
a feedback provider for both Microsoft when they made the token binding RFC and Google when they thought about removing token binding from Chrome. And a lot of the concerns we had going into this was that you've essentially bound the TLS client to a single TLS server, and you'd be re-authenticating the user all the time because servers change, they scale, they grow, they shut down, they're ephemeral in the cloud, and clients move. You go from a cafe to your home to your corporate office. Like everything that that is used to make a TLS session is always changing. So it was a super invasive, bad process in practice. So we were never a giant fan of it. So I guess to make this into a question is have you done any research into distributed proof of possession, or DPoP, which is what we've been thinking about as the sequel to token binding, which uses some cryptographic primitives based on, again, with hardware and host-based security, but not putting it to the TLS session for portability reasons.
Well, token binding is just a suggestion, right? So it's just food for thought for a maybe different type of binding the session. But the in my opinion, and like the point is that I'd like to raise awareness that sessions are being can be replicated, and this should be solved. This can be resolved by usage, maybe geographic location of attacker, and like monitoring. There are many ways to do that, but token binding is just one of them.
Yeah. Thanks for the answer. I appreciate that was a bit of a hard question, but
Okay,
I mean,
so maybe
you
you can come up and we can continue this talk.
I want to see your thunder. I've got my own talk to ruin later.
Okay.
All right. Thank you so much. Take care.
All right. So thank you so much for listening.